This is the access control system, the first of many systems that will be described in this course. Every system description will have a short narrative, common interfaces, some notes associated with those interfaces, some typical drawings, a commentary, which you may be listening to now, and any reference suppliers or manufacturers which we utilized to prepare this presentation on the access control system. But as you can see, there's quite a bit of interfacing going on with the access control system. I'll leave it to you to read this bit here. You can pause the video and read it if you'd like. But let's go into the common interfaces. Again, what we'll be talking about is the interface, whether it's physical, whether it has a gigabit backbone data network interface, cabling, which would be your Cat6 or fiber horizontal distribution systems, and any type of messaging that may be sent to or received from the access control system. If you notice the door hardware and metal frames and all that, that's primarily a physical interface where you have to coordinate the door hardware, you know, the handles and all that stuff, with the access control equipment so that you can lock, unlock those various doors. Now normally you can get the door hardware from the manufacturer, but you have to make sure you get the interfaces right so that the access control system can be wired to the door to control the lock. Conversely, you can get the hardware from the access control manufacturer to incorporate in the door. Now that becomes problematic because then you end up either having to ship the hardware to the door manufacturer so they can build it, or you have to try to do it on site. That is not recommended because most of these types of doors have some form of fire rating. So it's much more beneficial, both in time and cost, to just specify that the door manufacturer must include the door hardware interface type, which you can define, and have them install it so that you maintain your fire rating on the door. With regard to the gigabit network, sometimes the access control system server will talk to other servers. That's why you have a gigabit backbone network interface. So in the case of, say, building management system, you may want your access control system to talk to the building management system such that if the building management system has some type of fault that perhaps the building management system is monitoring some power, you want to notify the access control system that you may have lost power to some number of locks. This means that if there's a power failure, the doors would be unlocked so that if anybody's inside, they could get out. You may also want them to interface to your operational database, because in the operational database you have details of all the people with access control cards. That same information would be sitting in the human resources personnel file for the same user. Now, what becomes problematic is the way you put the cardholder's name in the system may be different than what's in the human resource system. You have to be careful attention to that, because in the case of a terminated employee, normally it's human resources would find out first. Then somehow they have to tell the access control guys to remove all access from that person's card or disable the card. Sometimes this takes a day, an hour, but nobody knows how long it's going to take. So ideally, if a person is terminated or restricted access to certain areas of the building for whatever reason, you'd want that to get immediately into the access control department where that person's access rights could be updated. So those types of interfacing and messaging would happen in your requirements phase. Another simple interface may be the clock system. When you're sending messages around an airport or any facility for that matter, you need date and timestamps on all messages. So you want to make sure that the time that's sent on the message is the same time as everybody else is having the same time. And that's what the clock system does. Now, with regard to messaging, you can send a complete database from the building management system and access control system. You can share the complete database, but obviously you don't want to do that. In database management or information management, you want to make sure that only the owner of the information can change that information. So when you send messages between various systems, you need to make sure that that message that you're getting you actually want. Otherwise, you're going to load up your data network, your gigabit network, with a lot of superfluous information and messaging that you don't need. Now, that can be done in several ways. Number one is you can have it defined in your operational database as an operational database structure for that information. Or you can use your information broker that can grab an entire message and strip out only what you need and then reformat it and send it to your server the way you want it. So those are two ways that you can do it, and that's typically the way it's done these days. That being said, some airports prefer an operational database methodology over an information broker. That way you're ensured that all data in all the databases, you have a clear and concise owner of that data. So you know what to do with the information. You may or may not want it to change what you're doing. We'll talk more about data synchronization and database synchronization later, and probably we'll cover that in more detail in the Flight Information Display System section of this document. Now, I've also described the physical gigabit cabling messaging interface details as notes. And again, I've talked about the messaging here that will be developed as a result of your data requirements phase. And you'll detail that in your interface control document or your interface design document. Those are the two typical terms which you use to define your interface between two systems. Almost all systems will have some type of typical drawing associated with it. In this case, you can see your servers. You can see here your gigabit backbone data network. You can see some horizontal cabling here with an Ethernet hub. And then you see all your various devices that you'll be using in your access control system. Now, these door control modules are not installed in the door itself. It'll be located somewhere close to the door because the wiring between this module and the backbone data network is slightly different. This is going to be your Cat6 cabling here, and this is going to be your local wiring by your access control guy. Now that person typically, that access control person will typically be responsible for this part of the cabling down here. And there may be an interface point located close to, adjacent to, or with inside of this control module box that could be provided by your Cat6 cabling contractor. It all depends on how it's tendered. Okay, so again, you've got all your door control modules. This is a bit of a Wi-Fi here, so there may be a Wi-Fi interface in this particular system for some remote portable access control modules that maybe some security guys carry around. So if you notice this Wi-Fi module, and we go back up here to our interfaces, you don't really see a Wi-Fi. Okay, now that could be included in the local area network, but for clarity's sake, and the reason I left it out is because most people forget that they need a Wi-Fi connection to the access control system. These were some, not necessarily errors, but omissions from specifications that I was previously involved in where we were implementing the system. So this Wi-Fi connection became an area of dispute. Okay, so it's very important to include whatever you can, which means that when you're looking at your interfaces, have a look at your typical drawing that you would have for your access control system from whatever vendor you select, and look for those various elements so you can define very clearly where the access control person's scope of work starts and ends, and other contractors' starts and ends. For example, you see CCTV fire intrusion detection system on this drawing. However, as indicated by the standard interfaces, you've got your servers as well, and an information broker and AODB, which you do not see on this typical standalone system. That's something to keep an eye out for when you're tendering and when you're writing your specifications, to make sure that you've got a interface defined onto the backbone network going to other systems. Again, looking at this drawing, you will see several. Anything that has anything to do with messaging or gigabit means you need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 other interfaces, which are not shown on this drawing. So that's why it's very important when you write your specs that you prepare something similar like this yourself in your specification, so that you can put all those interfaces on this drawing, a simple system drawing, and all the interfaces to others, where you can very clearly define what this guy has to do and what his obligations are under his contract. Here's another view of location for your access control system. And if you look at a typical terminal building, kind of like a nice little drawing, you'll see they have some control rooms. So you know you're going to have to put some equipment in a room. But what's really important about this drawing here is that when you're designing an access control system, there are very significant interfaces to your fire alarm system. So this could be a zone for fire, this could be a zone for fire, this could be a zone for fire, and the main terminal and parking could be a zone for fire. So why is that important? Well, if you have a fire here, okay, those people have got to get out of the building. Okay, so you may or may not want to open doors going out the loading bridge and down onto the apron, especially if they have a escape path going down this way. And for sure, you don't want to do anything with these other doors and access points around here, because obviously you don't want passengers hanging around the airplanes. Now, your architectural plan, which we talked about in the earlier parts of this course, will define the zones. So it's up to the architect to define how they can get out of this area in case of a fire. Okay? In this case, that little slot right there may be an exit point for passengers if the fire is happening around this area, because there's no other way for them to get out. Okay, so zoning with your access control system needs to be very carefully coordinated with your fire alarm evacuation system, and in some cases with the public address system. If you have a problem over here, you don't want to necessarily tell all these people down here over the PA system that there's a problem. You want to maintain calmness in your airport. You don't want to create a panic where they all start racing towards this area when they don't need to. So that's another area that you need to pay attention to, is the zoning associated with access control as it's coordinated with your fire alarm system and perhaps public address system. Now, in the ebook, you'll see this narrative I've just gone through in a link here, which in the future, if you click on that, you'll be able to see this video. Now, in this case, I've used a couple of systems for their pictures, so they're getting their credit for the pictures. I've used both of these systems on previous airports, and they both are pretty good systems. I knew CEM before they were bought up by Tyco. So this is the layout really of how you're going to see each of the systems that are in the total course, and we will go through every single system like this with the description, common interfaces, typical drawings, a narrative, and references. Hope you enjoy this video. If you have any questions, we have the Facebook group for all the students to join where you can ask questions, or you can email me directly. Happy learning.